Hi grade 11s, we're on to the second video, which is topic 2 within Trig questions. Now that we've done the basics of grade 10, we're going to start moving on to some more grade 11 type questions. So this first topic is something which I call Pythagoras type questions. And you're going to soon see why I call them that. And hopefully quite soon you're going to start to get used to the way in which these questions are asked, so you start to recognize them. So we're just going to do a couple of questions together. So you'll notice example 1 says consider the diagram below, and the moment I look at the diagram I'm like, oh gosh, this is a Cartesian plane. So we're talking about Cartesian plane definition of trig. As I've said before, most of the trig we're going to do is going to be our Cartesian plane definition. So we've got to remember the shield your rear, because x-rays tan your exterior. That's the definition we're going to use. We're not going to talk about opposites, adjacents and hypotenuses at all, because this is not a right angle triangle. So this says, consider the diagram below where theta is POX. So P is the point, which they've told me is negative 724. O is the origin, and X stands for the x-axis. So they've labeled in my angle of theta. It clearly is an obtuse angle. It goes into quadrant 2, and they've given me the point of P. Now, the most important thing with Pythagoras type questions is you start realizing that it's all about a diagram, and then it's all about finding X, finding Y, and finding R. It's never about finding the value of theta, because you'll notice that every single one of these questions says without a calculator. Now there's no way to find theta unless you have a calculator. So basically I'm never going to find theta, which means this all comes back to the definitions. So if I know x, y, and r, I can figure out cos, sine, and tan just by using my definitions. Now, what have they given me so far? Well, they've given me the x value. I know that x is negative 7. They've given me the y value, which is 24, and I don't know the r value. And this is exactly why they're called Pythagoras type questions. Because what is the only thing that connects x, y, and r are Pythagoras' theorem. Now, why does Pythagoras' theorem work here? I mean, Pythagoras' theorem works in right angle triangles, and I'm pretty sure I said not 2 minutes ago that there isn't a right angle triangle. Now, there is not a right angle triangle drawn, but I can construct myself a little right angle triangle here. Now, if I draw myself a right angle triangle, now this has nothing to do with the theta. It's just got to do with how is x, y, and r connected. So you'll know that this is the x value because it's how far along the x-axis you've gone. This is the y value, and this is the r value. So even though theta's got absolutely nothing to do with this right angle triangle, and I'm not going to start talking about opposites and adjacents and hypotenuses, because this right angle triangle has nothing to do with theta. However, I can see that Pythagoras' theorem is going to hold. So x squared plus y squared is going to equal to r squared because of Pythagoras. Now this is true in every single Cartesian plane you draw. The x value, the y value, and the r value are connected through Pythagoras' theorem. So in future I'm not going to draw my right angle triangle because I don't need to know it's there. It's got nothing to do with the question. It's just a connection between x, y, and r. So in this case x is negative 7, so this is negative 7 squared. Y is 24, so it's 24 squared, and that's r squared. Don't forget to put the brackets around the negative 7. Now, you don't have to show me any working whatsoever other than just showing me the answer. So you're welcome to just work out 24 squared and 7 squared on your calculator. Now, you don't have to show this. You get 625, which is r squared. So you square root. Remember, technically when you square root, you get the positive or negative square root. But r is a distance. So it can only be positive. Now that's not always going to be true. So simply because this is r, it'll only be positive because r is a distance. So don't forget the because sign, upside down therefore, because r is a distance. So I don't have to worry about the fact that there could be a negative 25. So I know r, which is 25, and I'm going to write Pythagoras. Now, this whole bit of working out that I did here, you don't actually ever have to show that. If you know this Pythagorean triple, as they call it, or you work it out in your calculator quickly, all you need to do is state the value of r and write in brackets where you got it from, which is Pythagoras. So if you're running short of time, you don't have to show every step where you actually show how to work it out. Now, once you've got x, y, and r, you have everything. I don't need to show any more working. I can simply just apply my definitions. So what do I mean by that? Well, I know the definition of cos is x over r. And so all I literally need to do is say that, right, I'm going to write my answers here just to create a little bit more space. So I don't even have to write x over r. You're welcome to go straight to the substitution step. These are notes, so I'm writing, a little bit more information that I would in an exam. But the x value is -7 and the r value is 25. So that is the value of cos theta, even though I don't actually know what theta is. Now, for the second question, I have sine theta. I know by definition sine is y over r in the Cartesian plane. You don't have to show that. You could just go straight to the fact that it's 24 over 25. And last question is question C, which is tan of theta. By definition, in the Cartesian plane, that's y over r. So in this case, this is 24 over -7, which I would probably prefer to write as negative 24 over 7, as we don't like negatives to really be at the bottom. And that's a Pythagoras type question. We call them Pythagoras type questions because x, y, and r are connected to the Pythagoras' theorem. They generally involve a sketch, and it's always without a calculator, which means you never actually work out theta. All you do is work out x, y, and r, and then you can do any question you like. Okay, so now there's various ways that they can ask these Pythagoras type questions. So let's look at example 2. So example 2 is a very common type of example. This question says if sine of theta is equal to -3 over 5. So immediately they've given me information number 1. Now by that, I mean I know that sine is negative. The reality is you have to find what quadrant you're working in. So my first step is to draw a sketch to locate the quadrant. If I don't know what quadrant I'm working in, it can lead to problems, and I'll explain to you why. So draw a sketch to locate the quadrant. So let me erase that. To locate the quadrant. So in this particular step here, they've told me that sine is negative. I know that sine is negative in 2 quadrants. So therefore, I could be talking about quadrant 3, or I could be talking about quadrant 4. So because this is all stations to Cape Town, I know that I can't be talking about that and I can't be talking about that. So I have to be talking about 3 or 4. Now the second bit of information they give you, because as you would have seen from our previous video when we were trying to isolate what quadrant we were talking about, you needed 2 sets of information to work out which quadrant you were in. So information number 2 says from 0 to 270, which is from there all the way around to there, which means, quadrant number 4 is out. So my first step, I've done this step already. Let me just erase that. Whatever angle theta is, it must be somewhere going into quadrant 3. So that's my first step. My second step is to remember the whole aim here is to find x, y, and r. If you look at the instruction, it says using a sketch, which we have done, and without a calculator, which means I need to be finding x, y, and r, because then I can do anything. So our second step is, why did I need to know what quadrant I'm in? So I now need to use the quadrant to write down the signs of x, y, and r. Now, I know that r is always positive, but x and y are positive or negatives depending on what quadrant they're in, and that's why you needed to know it. So I'm now going to use my quadrant to write down the signs of x, y, and r. Okay, well, if I just look at this, the sign of x, if I'm talking about an angle in the third quadrant, that x value will be negative, the y value will be negative, and the r value is positive. Right, my third step is to find x, y, and r. Once I found that, I'm A for away. So how do I find x, y, and r? Well, let's go back to this -3 over 5. They've told me that in this case, sine of theta is equal to -3 over 5. Now, what is the definition of sine? The definition is y over r. So y has to be 3. In fact, it's negative 3. You never know whether that negative technically belongs to the 5 or to the 3. Now I figured that out. I know from my picture that y must be negative and that r must be positive. So I now know that the y value is negative 3 and the r value is 5. Now I've found 2 of them, and so how do I find the third? And that's where Pythagoras comes in. So I'm just going to write a note here, and I'm going to say use Pythag to find the third. Now in this case I'm definitely not going to actually do any working, because we start to know what we call our Pythagorean triples, and the Pythagorean triples for 3 and 5 is 3, 4, 5. So you can do working if you want. I'm going to say 4 and just write Pythagoras because I know that out of my head. Now notice, if you haven't done step 2, so if you haven't figured out the signs first, you would never have thought to put a negative in. Now just to show you what Pythagoras' theorem would look like here, you would have said, I don't know what x squared is. I know y is negative 3, so squared equals 5 squared. So you would have said x squared plus 9 is 25, and you would have got x squared is 16. Now most people will just square it and get 4, and never even dream that you could actually be talking about negative 4 and how do you know the difference. So that's why this step number 2 of figuring out your signs first is really, really, really important. So now that I know that, you can do anything. Any of these questions I can do by simply just using my definition. So let's look at A. Question A says, what is cos of theta plus sine of theta? Now because we've practiced one before, I'm going to start cutting corners. I talk this through in my head. I said to myself, okay, well, what is the definition of cos? Cos is x over r, and sine is y over r. So I'm just going to put a bracket around that. It's a bit easier. And then that is just negative 7 over 5. Notice I never found theta and I never used a calculator. So all of these questions are now very easy because I just use x, y, and r in the definition. Okay, I raised some stuff just to give myself some space. What is tan of theta is b? Well, tan is y over, or I should say y, so I should say negative 3, my apologies, y over x, and so that is, I should never put 2 equal signs in a line, so let me rather put it below, that's 3/4. Now tan ends up being positive, which makes complete sense because you're talking about quadrant 3. Right, so let's look at question C. Question C says, what is sine of theta divided by cos of theta? So sine is y over r, divided by is easier to do here because otherwise I get a fraction within a fraction, x over r. Now because it's said without a calculator, I think I need to do some tippings and timesing and show some working. So if I tip and times, my r's cancel, and guess what? I get negative 3 over negative 4, which is 3/4. Now that's something which I'm just flagging because it's going to be really important in a little bit of time. The fact that sine theta divided by cos theta lands up getting you the same answer as tan. Now, is that always true or not? We're going to investigate that later. And our last question here is cos squared plus sine squared. So I'm sorry, I'm running out of space here, so it's a bit all over the place. Cos squared plus sine squared. Cos squared would be negative 4 over 5 squared. Sine squared would be negative 3 over 5 squared. That would be 16 over 25 plus 9 over 25. And again, sorry, running out of space. I add my numerators together and I get 25 over 25. And what do you know? That's equal to 1. Now again, I deliberately chose these examples because I wanted us to notice something. Do we notice that cos squared plus sine squared got us to 1? Now, why did that happen? Well, have a look what the numerator became. The numerator became x squared plus y squared, which, guess what, is equal to r squared. And the denominators were r squared. Now, if you don't know what I'm talking about, really, don't worry at all. These are called trig identities. I'm just sowing a seed here. And we're going to do a whole long section on trig identities in a couple of lessons' time. So I just like to use these examples to kind of give us a taste of things to come. But It's not important if you're a bit lost of what I'm trying to say. Ultimately, are we okay with our 3 steps? Sketch to locate the quadrant, write down the signs of the x, y, and r, and then actually work out x, y, and r. After that's done, the question's actually really easy. Okay, let's do a couple more questions. Right, if 8 tan theta minus 6 equals 0 and cos theta is less than 0, without a calculator determine sin theta. Right, first bit of information. Now, interestingly, I've deliberately given it to you in a different way because I want you to realize that you need to isolate my trig ratio first. You need to know some information about the trig ratio, not about a whole mush of it. So I'm going to isolate my trig ratio first. Now, 6 over 8 technically can simplify. It doesn't matter if you don't simplify it, you're still going to get exactly the same answers, but simplifying makes my life easier. So there's information number 1. In example 2, I gave that to you, sin theta equals. Here I made you work for it a bit. So don't forget here, if it's given to you like this, you need to isolate your trig ratio. So what do I know so far? Step number 1 is, can you isolate a quadrant? Well, at the moment, I know that tan is positive. And so if tan is positive, it's either in quadrant 1 or it's in quadrant 3, because it cannot be there and it cannot be there. Now, our second bit of information is cos is negative, which means now it cannot be in quadrant 1. So once again, we have an angle just per chance, which is landing up in quadrant 3. Now again, really, really important. Fill in your signs of x, y, and r before we go anywhere. So the x value of an angle in quadrant 3 would land it to be negative. The y value, that's in the negative region of the y-axis, and r is always positive. Now step number 3 was actually to go and fill in those values. Now look at what they've given me. They've given me 3 over 4, and the definition of tan is y over x. So y must be 3 and x must be 4. Now notice, if we hadn't filled in those signs, why would you ever have thought that technically this was negative 3 over negative 4 and those negatives simplified away? You wouldn't think that y could possibly be negative as well as x. So that step of finding the signs before you even go anywhere is vitally important. Okay, now don't forget, we need to use Pythagoras' theorem to fill in the missing link. And once again, this is a Pythagorean triple. So this is 3, 4, 5. And you don't have to show any working as long as you write Pythagoras. Once you've done that, the question's really easy. This question says determine sine of theta. Now sine of theta is quite simple. Sine by definition in the Cartesian plane is y over r. So in this case it's negative 3 over 5. Now it makes sense that it's negative because I'm talking about an angle which is in quadrant 3 and sine is negative there. Right, 2 more, a little bit more interesting questions to go. So example 2 and 3 are your kind of classic Pythagoras type questions. So let's look at some more interesting ones. If sine of 65 equals m. Okay, so now they actually haven't told me what it equals to. Determine the following in terms of m. Now in an exam it'll probably also say without a calculator. So sine of 65. Now this is actually quite nice because it's a bit weird. They've given me the angle. So I know that this is 65 degrees. So it's there. That's wonderful. It's equal to m. Okay, now what's the definition of sine? Notice this is very different because do I have to determine the quadrant? No, it was given to me. I should probably fill in my signs of x, y, and r because it's just helpful. Now this is quadrant 1, which means everything's positive. Now what's the definition of sine? Sine by definition is equal to y over r. So y over r is equal to m. So how do I write m as a fraction? It would be m over 1. So I now know that y is m and r is 1. So this is very similar to your Pythagoras type questions from 2 and 3. It's just a little bit different in that they've told me the angle and yet they haven't given me the ratio. So everything is going to be in terms of m. Now Pythagoras' theorem says that x squared plus y squared is r squared. So I'm going to have to do a little bit of work here because I need to find x. So x squared plus m squared is 1 squared. So x squared would be 1, which is 1 squared, take away m squared. Now x would either be the positive square root or the negative square root, but in this case I've already indicated that x was positive. So now I know that x is the positive square root of 1 minus m squared. Now once again I've got x, y, and r, and I can do anything. So this is a slightly different question to example 3. Now a different way to do this would be, we don't have to think of this as a Cartesian plane. We could think of this as a right angle triangle. Why? Because 65 is acute. So I could put 65 degrees in there. And then I could say, well, if sine of 65 degrees is equal to m, which is technically m over 1, the definition in a right angle triangle would be opposite over hypotenuse. So that means my opposite has a value of m, my hypotenuse has a value of 1, and I would have done exactly the same working out to work out my adjacent. So my adjacent is 1 minus m squared. Now you can work with either definition. You could work with the opposite, adjacent, and hypotenuse, or you could work with x, y, and r, and you'd still get the same answers. Now the reason why I like a right angle triangle here is because once you have one angle in the right angle triangle, you can work out this angle, because that angle there is 180 minus 90 minus 65. So if I work that out, I get that this is 25 degrees. Now why that's nice is if you ask me anything about 25 degrees, I actually know the opposite, the adjacent, and the hypotenuse of 25. So we're going to come back to this type of example in the future, and we're going to look at using a right angle triangle quite a lot. Okay, so that was definitely quite a difficult question. Now we haven't actually done the answers to the question, but I can see a typo in my work here. So I see cos of theta, this should be cos of 65, and tan of 65, because I actually knew them. So what's question A? Well, I should say cos. Question A was cos of 65. If you had drawn the Cartesian plane, you would say technically cos is x over r, which in this case is root 1 minus m squared over 1, which is root 1 minus m squared. If you had used the right angle triangle, you would say cos is adjacent, so I'm going to write here, or you could say adjacent over hypotenuse. It depended which type of method you'd used. Our second question, tan of 65, again, very easy, just different methods. You could have said that's y over x, or you could have said that's opposite over adjacent. Either way, you're going to get the fact that it's m over root 1 minus m squared. Now this is definitely the more difficult type of question, and we are going to come back to this type of question towards the end of the section. Okay, let's just try one more, which is interesting. This question, as you can see, looks very similar. So it says cos theta, now they haven't given you theta, so cos theta equals p, and they've told you which quadrant it's working in. Now notice this can't possibly be a right angle triangle, because they've told me that it's from 270 to 360, which means all the way around in quadrant 4. So there is this point, whatever this point is, I'm going to call this point B. So what are my signs of x, y, and r? I'm going to treat this exactly the same. I've drawn a sketch, I've isolated the quadrant. So my sign of x here, this will be a positive x, my y would be negative, my r is always positive. Now I go to my definition of cos. Cos by definition is equal to x over r, which in this case is p. So there's an invisible 1, so x is p and r is 1. So this is almost exactly the same as examples 2 and 3. It's just using a letter and not a number. Now again, we're going to have to use Pythagoras. So we're going to say x squared plus y squared is r squared, Pythagoras. And you'll notice this is very similar to the previous calculation. So p squared plus y squared is 1 squared. So y squared would be 1 minus p squared. And then I would square root. Now don't forget, this could be the positive or negative square root. So how do I know? Well, I'd already decided this was the negative. So because I'd made that decision based on the quadrant, I know this is the negative square root of 1 minus p squared. Now notice I can't draw a right-angled triangle for this because this angle would never fit in a right-angled triangle. But once I've found my little shopping list of x, y, and r, sine is easy. Sine is y, which is negative root 1 minus p squared, over r, which would simplify simply to the root. And then tan of theta, by definition, is y, so it's negative the root all over x, which is p. So you'll notice a similarity in example 5 and 2 and 3, and 4 being the one that is quite different. Now these questions are really popular, so there's going to be a lot of practice necessary in order to get this perfect. We do revisit examples like this later on.